Dear friends, I myself, Dr. Bharat Parab, discussing the topic deductive reasoning. This is covered in Appendix 1 and used in many topics in maths. Okay. Deductive reasoning means we arrive at a result, that is, we deduce or in fact we infer a statement from a previously established statement using logic. The exact meaning of this will be known to you as we move ahead in this video, okay, on this topic. So we start with these two examples. Look at these examples. A. Arun is a clever student. Okay, read this statement clearly. This does not mean that others are not clever. Okay. He is talking about Arun at this moment. Got it? Arun is a clever student does not mean others are not clever. Okay. And B. Arti doesn't like non-veg. Okay. Now go through this intelligent comment here. This doesn't mean that Arti likes veg food. Arti doesn't like non-veg does not mean that Arti likes veg or veg food. Or see, Arti doesn't like non-veg. It's talking about Arti doesn't like non-veg. Does not also mean that others in the friend circle likes non-veg food. Okay. The statement says only about Arti and non-veg. No converse statement of this is applicable. Okay. So we see some examples here where deductive reasoning has been used. Okay. Some simple examples and see how a logic has been used. First one, reading it, we get a large number of fishes if it's high tide on the previous day. Okay. If we get a large number of fishes on Sunday, it means it was high tide on Saturday. See, we were not present on Saturday. We have not seen. But if this statement is true, and if we get large number of fishes on Sunday, that means it was high tide on Saturday. So we can conclude this from the statement. This okay, from the statement we know by logic that we get a large number of fishes if it's high tide on the previous day. Okay. Now second one, we know that lunar eclipse, that is moon eclipse, always occurs on full moon day. We know this. Okay. If we are told that lunar eclipse was on 21st Jan, means it was full moon day on 21st Jan because lunar eclipse always occurs on full moon day, and solar eclipse always occurs on no moon day. Okay. If we are told that solar eclipse was on 24th June, means it was no moon day on that 24th June on that day. Okay. So we are using logic. This use of logic is called as deductive reasoning. Okay. Third one, if a student scored 60% or more, then only he or she will be transferred to division A. Okay. And if Sudha has been transferred to division A, infers that she had scored at least 60% in the said exam. Got it? Read it, think over it. It's very easy. Okay. Now we will try to see some examples where a deductive reasoning has been used. Very intelligent way of reasoning. Okay. See your first one. You are given four cards having a picture of moon or sun on one side, moon or sun on one side, and dark and light. Now this dark and light is related to sun and moon on the other side. Okay, there are two sides. Okay. Now these are four cards. ABCD. Suppose you are told that these cards follow the rule as. Now the rule given, read this very carefully. If a card has dark on one side, okay, then it should have moon on the other side. Try to follow this rule very carefully. If a card has dark on one side, then you should have moon on the other side. That's the rule. Okay. We can open all four cards and check. Okay, check for the validity of the rule. Okay. But what if we have to open minimum number of cards to see the validity of the above rule? Okay. For this, we will use certain logic, and this logic is called as deductive reasoning. Okay. We will see this in answer part. Answer. We can have following combinations. Okay. Dark, moon, light, moon. So moon can have either dark on this side and light on this side. Okay. Now dark, sun, light, sun. Sun can have dark on this side and sun can have light on other side. Okay. Now look at this comment very carefully. The converse of this rule that if the moon is on one side, okay, then it should have dark on the other side is not applicable. Okay, got it? The rule is if card has dark on one side, then you should have moon on the other side. But if it has moon on this side, one side, then it should have dark on the other side is not applicable. Very interesting and very intelligent reasoning. Okay, now try to understand this. It's talking only about dark. If there is dark, you can see dark, then you should have moon. But there is moon on that side, okay, then it can have anything on this side. Got it? So converse is not true or converse is not applicable. Hence combination 2 here, light moon. If there is moon, can have light is also possible, and it doesn't break the rule. Okay, it's not talking about moon. It's talking about only about dark. Okay, if it has dark, then it should have moon. If it has moon, it's sure dark. It doesn't say like that. Okay, so this can have dark and this can have light, because even if there is light on that side, it doesn't break the rule. Rule still valid, right for this, or valid is good. Okay, so no need to open A. For D, okay, I am going literally very slow for you to understand this, because this is literally easy but little complicated. Okay, for D we can either have second and or fourth combination. Light can have moon on that side, and here light can have sun on that side. Okay, if this has moon on that side, okay, it doesn't break the rule, and if this has sun on that side, still it doesn't break the rule. Okay, so any of this doesn't break the rule, so we need not open D. So this shows that. Okay, okay, but if B has dark on the other side, B is sun on this side, now this should not have dark on that side, because rule says if there is dark, there has to be moon on this side. Okay, so if B has dark on other side, then it will be S3, and which breaks the rule. Okay, so we have to open B and C, and of course we have to open C, as is a shows condition starts with dark, so we have to open dark and see whether it contains moon or sun on that side. If it has sun on that side, they can break the rule. We have to open that whether to check whether there is moon on that side or not. Okay. So hence we have to open B and C to check for the dark or moon and validity of the rule. Okay. This reasoning is called as a deductive reasoning. Okay. Try to listen to this video. I have covered many other examples also. So try to understand this, think over it, and still if you face difficulty, okay, write to me in the comment section. Second example, you are given 4 cards having a picture of a girl or a boy on one side and letter B, G for boy, and letter G, G for girl on the other side. Okay. Suppose you are told that these cards follow the rule as. I am reading the rule. Okay. Try to understand this carefully. If a card has a boy on one side, then you should have a B on the other side. What is? Reading it again. If card has a boy on one side, then it should have B on the other side. That's the rule. We can open all 4 cards and check. But what if we have to open minimum number of cards to see the validity of the rule? We will be using certain logic. Okay. So answer. We can have following combinations: boy B, boy G, okay, girl B, girl G. All these combinations we can have. Now read this very carefully. I am again reading the rule. If card has a boy on one side, then you should have B on the other side. What's the converse of this rule? The converse of this rule that if B is on one side, then it should have boy on the other side is not applicable. Okay, got it? So this can have boy on that side, and this can even have girl on that side. Okay. Similarly here, this can have B on that side. Okay. This can have G on that side because rule doesn't say anything about the girl. Okay. Got it? Try to understand this. So converse of this rule that if B is on one side, then it should have boy on the other side is not applicable. Hence combination 3 here, girl B is also possible. So this can have girl on that side and this can have B on that side. Okay. And if that's the case, it doesn't break the rule. Okay. So it's possible and it doesn't break the rule. So no need to open Q. We need not open Q because whatever either B or G, whatever combination is there, it doesn't break the rule. So we need not open Q. Okay. For R now, similar thing. Okay. We can have this combination first or third. Can have boy on that side, no problem, and we can have girl on that side. Still rule holds good. Okay, it doesn't break the rule because a rule doesn't specify anything about a girl. Okay, so for R we can have either first or third combination, and any of this doesn't break the rule. Okay, now interesting point is there. Now if P, that is this card, we have taken decision about these cards, so no need to open this. Now we are talking about this and this card. If this has G on that side, okay, then rule violates or breaks the rule. Okay, and if this has boy on that side, then again violates the rule. Okay, if there is a boy on that side, then should have B on this side. Okay, so see here, if P means this, has G on the other side, then it will be this combination which is not allowed. Okay, boy, then it should have B. This combination is not allowed. So we have to open this and see that whether it contains B or G. It should not have G. Okay, so we have to open this. Which breaks the rule. And we have to open this, of course, to see whether there is boy. If there is boy, then it breaks the rule. Okay, so hence we have to open P and yes to check for B whether there is really B or not, and boy, there is no boy. Okay, so that it doesn't break the rule. This reasoning is called as a deductive reasoning. Okay, got it? Third example, you are given four cards having a picture of an apple or a rose on one side, apple or rose on one side, and A and R on the other side. Okay, J, K, L, M, you have labeled them for simplicity. Suppose you are told that these cards follow the rule as, try to understand this rule properly every time. If a card has A on one side, then it should have an apple on the other side. Okay, it's talking about A, and if it has A on one side, then it should have apple on the other side. Try to understand this. Okay, we can open all four cards and check, but what if we have to open minimum numbers of cards to see the validity of the above rule? Okay, so we will be using certain logic and we'll just check what logic has been used. It's very intelligent logic. Answer, we can have following combinations. We can have A and apple, this is one side, this is another side, R apple, R rose, A rose. Okay, now try to understand this. Okay, the converse of this rule, what rule? If card has A on one side, A on one side, okay, then it should have apple on the other side. Okay, the converse of this rule is if an apple is on one side, then it should have A on the other side. Okay, is not applicable. Okay, if you see apple, then it doesn't say that it should have A on the other side. It's not compulsory. Okay, can have anything. Here, this can have A on that side or R on that side. Anything on that side doesn't break the rule, because rule is if card has A on one side. Okay, rule is only for A, not for apple. Okay, remember that. So hence combination 2 R apple, this can have R on the other side, is also possible. It's possible and it doesn't break the rule. Okay, got it? So we need not open this. So no need to open J, this card. For M, okay, now we can have either, now this is R, we can have either second or third combination, this and this. R can have apple on the other side and can have a rose on the other side, but rule doesn't contain anything about R, so this may have apple on the other side, or even if it has a rose on the other side, it doesn't break the rule. Okay, so we need not open this also. So this is marked like that. So it's given here. For M, we can have either second or third combination, and any of this doesn't break the rule, so we need not open this. But if K means this, has A on the other side. Okay, if we have to open this because we have to check whether if this has A on the other side, then it breaks the rule. Okay, so for that we have to open this. So see, if K means this, has A on the other side, then it will be as 4. Okay, rows A. Okay, which breaks the rule. Okay, and if this has rows on the other side, then again breaks the rule. This must have apple on the other side, but we will not come to know unless otherwise we open both these cards. Okay, so we have to open this and this. That is what is given here. Okay, hence we have to open K and L and check for A. Okay, and an apple respectively. This reasoning is called as a deductive reasoning. Okay, understood? For example, you are given 4 cards having a picture of a hand or legs on one side and cap or shoe on the other side. We have labeled them like that: H for hand, L for legs, then C for cap, and S for shoe. I have deliberately chosen all 4 pictures and no letters this time for better understanding. So we are going to read this rule and try to understand the rule. Okay. Suppose you are told that these cards follow the rule as. Okay. Now read this very carefully. If a card has legs on one side, it's talking about legs now. Okay. If card has legs on one side, then it should have shoe on the other side. Okay. Now these are two related. Okay. So then it should have shoe on the other side. So we go ahead. We can open all 4 cards and check. But what if we have to open minimum number of cards to see the validity of the above rule? So we will think on the logic we are going to use, which is given in answer. Answer: we can have following combinations: hand, cap, hand, shoe. Okay. Then legs, cap, legs, shoe. Okay. Now see here, the converse of this rule, that if the shoe is on one side, okay, we was talking about legs on one side and it should have shoe on the other side. But converse, that if shoe is on one side, then it should have legs on the other side, is not applicable, or that is not compulsory. Okay, so if there is shoe, then other side may have legs or may have hand, because that is not compulsory. Okay, so converse of this rule, that if the shoe is on one side, then it should have legs on the other side, is not applicable. Hence combination 2, this yes, shoe and hand. Okay, combination 2, hand shoe, is also possible. This can have hand on the other side. Okay, or this can have shoe on the other side. Got it? Because both of this doesn't break the rule. So even this can have either cap or shoe, and either cap or shoe doesn't break the rule. Okay, because rule says legs on one side, then it should have shoe on the other side. Okay, so no need to open H. Similarly, for S, shoe, for S we can have either second or fourth. Issue here, here also on the other side we can have hand or leg, and any of these doesn't break the rule. So we can have either second or fourth combination, and any of this doesn't break the rule. So we need not open this. We have seen we need not open this, and now we have seen that we need not even open this. Okay, but if L has cap, L means this. Okay, has cap on the other side, then it will be 3, which is not allowed. Okay, got it? Think about it. Okay, you will get it. So we have to open this. But if L has cap on the other side, then it will be 3, which breaks the rule. Okay. Hence, now this, of course, we have to see if this contains legs on that side, then I can break the rule. Okay. Hence, we have to open L and C to check for shoe and legs. If there is shoe and cap, and this hand or legs. Okay. Now, this type of logic we have used for this is called as deductive reasoning. Okay. So let us repeat some examples of a deductive reasoning we have seen earlier. Okay, for some reason. First one, we get a large number of fishes if it's high tide the previous day. Okay, we have this statement. Okay, if we get a large number of fishes on Sunday, means it was high tide on Saturday. Okay, got it? We can conclude this from the statement we know by logic that we get a large number of fishes if it's high tide the previous day. Got it? You got Sunday, that means it was high tide on Saturday. Very simple. Second one, we know that lunar eclipse or moon eclipse always occurs on full moon day. If we are told that lunar eclipse was on 21st Jan, means it was full moon day on 21 Jan. Okay, and solar eclipse always occurs on no moon day. If we are told that the solar eclipse was on 24 June, means it was no moon day on 24 June. Okay, very simple. So we are using logic. Here we rely on the fact or those statements which can be proved and not on the hearsay or ambiguous statement. Got it? Not on hearsay or ambiguous statement. Like, see, there is an example here. Today, your friend is not taking lunch, means she is observing fast. Okay. It may not so happen that she must have had a lunch just before this. Okay. So, you should have some logic, some statement which is not ambiguous or not does not depend on hearsay. Okay, and such type of reasoning is called as deductive reasoning. Okay, now certain exercise on deductive reasoning, very interesting. Okay, first one, humans are mammals and all mammals are vertebrates. Okay, so this is common mammal word. Humans are mammals and all mammals are vertebrate. Based on these two statements, what can you conclude about humans? Answer: humans are vertebrates. Yes, clear statement. B. Anthony is a barber. Dinesh had his hair cut. Can you conclude that Anthony cut Dinesh's hair? Answer: no. Okay, because the statement doesn't specify anything about that. Okay, as some other barber might have cut Dinesh's hair. Okay, C. Martians have a red tongue, similar like this. Okay, Martians have red tongues, and Gulag is a Martian. Based on these two statements, what can you conclude about Gulag? Okay, answer: Gulag has a red tongue. Okay, because it's a Martian and Martians have red tongue. That means Gulag has red tongue. Okay, and D. If it rains for more than 4 hours on a particular day, the gutters will have to be cleaned the next day. Okay, for 4 hours. If it rains for 4 hours, gutter will be cleaned the next day. If it has rained for 6 hours today, what can we conclude about the condition of gutters tomorrow? Very simple. Answer: gutters will be cleaned tomorrow. Okay. So that is how logic in reasoning, that is deductive reasoning, is used. Okay. Now on the next one, okay, look at this cartoon. What is the fallacy in cow's reasoning in the following cartoon? The cow, okay, it's a tail and it is having some statement here. All dogs have tails. Okay, I have a tail. That is what she is saying. Therefore, I am a dog. Okay. Now answer: all those animals having tails need not be dogs. Even other animals like cattle, cats, monkeys have tails, and they are not dogs. Okay. So that is a fallacy in this cow's reasoning. Okay. Example 2 from book. You are given 4 cards. Each card has a number printed on one side here and a letter on the other side here. Okay. Which are the only 2 cards you need to turn over to check whether the following rule holds good? Okay, we'll read the rule now. Remember, letter means maybe consonant or vowel, or number means maybe even or odd. Okay, so we will read this. If card has consonant on one side, then it has odd number on the other side. That's the rule. Okay, so we will see the logic in answer part. Answer: we can have following combinations: consonant and odd on the other side, consonant and even on the other side, vowel, see it is here, vowel and odd, even it is here, and vowel and even. Okay, so if we look at this first card, this is consonant, so we have to check what is there on the other side because it must have odd number. Okay, so we have to check whether it doesn't contain even number. So anyhow we have to open this. So we have to open one to check for odd or even number. Okay, because we have to see whether the rule is not broken. Okay, now see the converse of this rule, that if the odd number is on one side, then it should have consonant on the other side is not applicable. Okay, If there is odd number, then the other side may have anything, either consonant or vowel, because that doesn't break the rule. Rule is for consonant and odd, okay, not for odd and consonant. Remember this. Okay, so for 2 we can have either, for this can have either first, that is odd and consonant, or third, that is odd and vowel, here any combination, and any of this doesn't break the rule, so no need to open 2. Okay, now for this, here for 3, if it has odd or even number on the other side, it doesn't break the rule. Okay, so we need not open even third one. Okay, so no need to open 3. But for 4, okay, we can have second combination, this which is not allowed, or fourth vowel and even. Okay, so if fourth card contains consonant, then it breaks the rule, so we have to check that. Okay, got it? Hence we have to open 4 to check for consonant and vowel. So in all or overall we have to open first and fourth. That's the answer. Okay, think over it, read it once again. Okay, if you need any explanation, I will explain. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of introduction to deductive reasoning given in Appendix 1, okay, if you have any difficulty, let me know through comment section and I shall solve it. Thanking you. Good luck.